All right, students, today we are starting on chapter 6 and we're skipping 6.1. We're going straight to 6.2. So, today we're going to be talking about theorems, and you are going to use these next 2 pages throughout this whole chapter. Okay? And stick with me. They have big names, but they can be understood. So, give them a chance. All right? So, first off, a theorem. What is a theorem? A theorem is simply a math rule. So a theorem equals a math rule. We're in 6.2. We're on page 194, if you're not there yet, but you're going to be taking notes on 194 and 195. So what is the perpendicular bisector rule? Perpendicular bisector rule. What it says, in a plane, well, okay, don't worry too much about that. If a point lies on a perpendicular bisector of a segment, then it's equidistant from the endpoints of that segment. What? So what that means is, here's a segment. So here's our segment. If a point lies on the perpendicular bisector, so this is segment A, B. So if we have a point, so here is a bisector, and it's perpendicular. So by bisector, it goes straight through, and let's call this P. So AP equals PB. So this right here is called a perpendicular bisector. Why is it a perpendicular bisector? Because it's perpendicular, right? It's at a 90 degree, and it's a bisector. It makes this equal to this. So it bisects this AB. So what it says is that if a point lies on this line, it's going to be equal distance from both A and B. So if I pick a point right here, this is going to be equal to this. Or let's say I pick a point right here. It means that this is equal to this. I should maybe use a ruler for those. But anyways, that's what it's saying. That if I pick any point on this line, how about this point? It's saying that this is equal to this. 1, 2, 3, 4. 1, 2, 3, 4. So any point on this perpendicular bisector, I'll make the perpendicular bisector blue. Any point on this perpendicular bisector is going to be equidistant from both A and B. That's all it's saying. So we're going to refer back to these theorems throughout our homework. So if this is a perpendicular bisector, which it is, that means that AC equals CB. That's your perpendicular bisector theorem. Now, there is converse of the perpendicular bisector theorem. That's the opposite. That means that if there is two lines, AD and BD, and they're equal, they're congruent, the two lines are congruent, and then a line forms perpendicular through that point, then it's going to cut this in half. Then it's going to make a perpendicular bisector. So, I'm not sure if that was a great explanation, but if I have these two lines, and I tell you that this is equal to this, and then I take a line from here and I make it perpendicular, if this line is perpendicular, then what it means is that I've cut this line in half. So it's just the opposite of what we just did. If these two lines are the same and this is perpendicular, then I just bisected this line. So let's say R, S, T, Q. If RQ is equal to TQ, I put a perpendicular bisector in here. It's going to bisect those. Okay? Just hang with me as best you can, and you'll see how these work in real life. So, If a point lies on the bisector of an angle. What's the bisector of an angle? That just means it cuts the angle in half. The bisector of an angle cuts an angle in half. It means you get two equal angles. So let's say I have an angle. Let's have an angle. And I have a bisector of that angle. That means the bisector is going to go right down the middle, meaning I have this is going to be equal to this. That is a perpendicular bisector right there. So let's say I have A, B. Oh, let's do different letters since there's A, B, C here. Let's do R, S, T. And let's do, what are we going to put here? Let's say P. So there's our points. And we just said from SRT, if we bisect SRT, that means that this angle, TRP, is exactly the same as this angle, SRP. So that's a perpendicular bisector. Now, if a point lies on this bisector, then it's equidistant from these two sides. If a point lies on the bisector, it's equidistant from the two sides. So if I make a perpendicular line, then this is equal to this. There you go. That's what that means. Now the converse is true, meaning that if I have a perpendicular line that's equidistant, another perpendicular line, if these two are perpendicular and equidistant, that means that this is an angle bisector, that AD is an angle bisector. So I know that is equal to this, then this angle is equal to this angle. So you had two theorems and two converse theorems that we just went over. I don't know if I explained. Converse is simply the opposite. So have the examples written in here. Have the examples written in, and then it's part of your homework. Let's go to here and see how it's going to work. So find the indicated measures, explain your reasoning. So let's see. We have here, so these two are equidistant. Those are equal, right? And this is perpendicular. So what that means is that this is a perpendicular bisector. So if I have a perpendicular bisector, what does that tell us about these two sides? Well, perpendicular bisector tells us that these two sides are equal. So that means that AB equals 9. And how do I know that? Explain my reasoning. I know that from the perpendicular bisector theorem. However you spell it, whatever. Perpendicular bisector theorem. Okay? All right, let's look at this. Number 3. We want to find out the length of SU. So this is equal to this, and this is perpendicular. So based on the converse bisector theorem, if I have two that are equal and a perpendicular bisector, it means that these two are equal. So that means that this 2x plus 2 is equal to 3x. So what's SU? Well, I don't know yet. I have to solve it, right? So minus 2x minus 2x. 2 equals x. So SU equals 2. No. X equals 2. Now I have to plug 2 back into here. 2 times 2 is 4 plus 2, so that's 6. So SU equals 6. How did I know that? The converse perpendicular bisector theorem. Oh my gosh, do I have to write all that out? That takes... Yes, you have to write all of it out. You have to write it all out. For credit, you have to write it out. Find the equation for the perpendicular bisector. I'm going to say if you're watching this video, you don't have to do it. If you don't watch the video, you're probably going to end up doing it. So watch the video, don't do it. All right. Number 5. Let's check these out. Find the indicated measure, explain your reasoning. So it looks like these are equidistant and they're perpendicular. So what that means is that these two angles are equal. So CAB, looking for this whole angle, so it equals 20. No, it doesn't equal 20. It equals 20 plus 20. So CAB is 40 degrees. And how do I know that? Because right here, I learned the angle bisector theorem. I learned that these two angles are equal. So angle bisector theorem. All right, let's go over here. Number 7. I've got perpendicular. So this, what they're trying to tell us is that these two are equal. So if these two are equal and these are perpendicular, then that means that these two are equal. So it wants to know what the length of BD is. So I know that 3x plus 1 equals 5x minus 1 minus 3x. So I get 1 equals 2x minus 1. Add 1. Get 2 equals 2x. Divide by 2. Get x equals 1. So BD equals 1. No, not so fast. I have to plug that into here. So 3 times 1 plus 1. That's 3 plus 1. So BD equals 4. Okay. There you go. Oh, wait a second. What is this? Oh, looks like we have a few more problems. So, tell whether it allows you to conclude that point P lies on the perpendicular bisector of RS or on the angle bisector. So, does P lie on the perpendicular bisector? Well, if that equals that, and this is perpendicular, and that equals that, then yes. Yep, it sure does. So this one, we have this one equals this one. They're perpendicular, so that would mean that this equals this. So we would say, yep. Okay, find the indicated measure. So, perpendicular bisector, you need to find AD. I think you got that. GJ, we're trying to find this. These are equidistant, and it's perpendicular, so that means that this equals this. So 4x plus 5 equals 2x plus 11. So we have a simple equation. So we need to solve this equation in order to find x. 4x minus 2x is 2x minus 5. So I get 2x equals 6. Divide both sides by 2, and I get x equals 3. Please remember that's not my answer. I'm looking for GJ. So I have to plug the 3 into here. 2 times 3 plus 11. So 6 plus 11. So GJ equals 17. What's my reason for that? Well, this is the perpendicular bisector theorem. Man, why do I make you write all this out? Because I'm mean. That's it. All right, let's look at this one. DGF. So I'm looking for this whole angle right here. So here's a point, and I want to see if it's an angle bisector. This is the same length as this. They're perpendicular. So this is, in fact, an angle bisector. So I have 3x plus 8 equals 5x minus 12, because this is equal to this. So subtract 3x, 8 equals 2x minus 12. I get 20 equals 2x. Divide both sides by 2. X equals 10. I plug the 10 back in. So let's do this. 3 times 10, that's 30, plus 8. So this is 38. This should be 38 also. 5 times 10 is 50 minus 12. That is also 38. So 38 times 2, or 38 plus 38. I get 76. So this whole angle right here, 76 degrees. And how do I know that? I know that because of the angle bisector theorem. All right, finish off all the evens for that. And please ask if you have any questions.